This is Britt Caswell with another example video. In today's video, I'm covering example 3 from lesson 6-1 in the SavvasRealize Algebra 1 textbook. In this example, we're going to look at what's called the power of a power property. So what a power of a power property is when you have some kind of exponent raised to another exponent. Alright, so here I have a to the m raised to the nth power. And so all that you do when you see this is you can multiply together those two exponents. So for example here, x squared to the third is the same thing as x to the sixth. And that's because what they're doing is they're saying when they cube this, they're saying they're taking x squared and multiplying it together 3 times. So this is like saying, oh come on now. This is like saying x squared times x squared times x squared. Squared, because we're cubing, right? And here, 2, 4, 6. That's where we're getting x to the sixth. Now understand the power of a power property is really powerful because it also works when you have multiple things being multiplied together. So here, xy squared being raised to the second power, I can use the distributive property in order to distribute this square. So this turns into x to the second, because there's an imaginary 1 here, right? And 1 times 2 is 2. And then y to the fourth, because 2 times 2 is 4. Now, you have to be very careful in a situation like this, or else you get this Drake meme. Oops. We cannot, absolutely 100% cannot distribute an exponent across addition. Okay, this is called the freshman's dream. Okay, made fun of so many people in college for this, guys. So you cannot take an exponent and distribute it. This doesn't work. Because what ends up happening is we have x plus y, and when we're squaring it, we're multiplying it times x plus y. And so when I go to use the distributive property here, I'm going to take x and times it to each of these terms. So x times x is x squared, and x times y is xy. And then I'm going to take the y and distribute it to each of these terms. So y times x is xy, and y times y is y squared. And then if you combine your like terms, you get x squared plus 2xy plus y squared. Okay, so do you see how if you just distribute this square, how you lose out on this middle term? It's not up here. So make sure that you don't make that mistake. Okay, only distribute that exponent across when it's multiplied. Okay, if there's a plus or a minus in here, get out of town. Alrighty. So now what they're doing here is they're showing us a kind of strange thing with your book. Okay, your book likes to do a lot of strange stuff in 6-1. And so these problems, they look very similar to the product to power problems, right? The only difference is that their bases here are different. And so what we have to do is we have to convert our bases until they match. Now 3, it doesn't really break down anything. It's just 3 to the first power. But if you notice, I can multiply 3 times itself a few times to get 27. So what I can actually do is I can rewrite that 27 as 3 cubed. And then it's raised to the x minus 4. And so now when you have it like this, now we can use the power of a power property, which says that you multiply these two exponents together. So this turns into 3 times x, which is 3x, minus 3 times 4, which is 12. And now we have that same situation that we had when we were doing the problems earlier, where we can take these exponents and set them equal to each other. And so that's exactly what I'm going to do. So 3x minus 12 equals 2x minus 6. All right, so now I just want to get all my x's onto one side, so I'm going to subtract 2x from each side. So I get x minus 12 is equal to negative 6. And then let's add the 12 over to get x alone. Okay, we call that isolating the variable, right? And negative 6 plus 12 is 6. Now it is always good practice to go in and plug in our values to check. I'm not going to do that right now just because I want to keep the video short, but just be aware you should always kind of check yourselves so you don't wreck yourselves, okay? So now let's check out this one. So here on the bottom, we're looking at 1 over 25, or sorry, 1 over 125 and 1 over 25. I kind of know this just from having experience with numbers. It might be a good idea for you to write down lists of, what power things are being raised to. But I could tell you that 125 is the same thing as 5 cubed. So what I'm going to do is I'm going to write this 1 over 125 as 1/5 to the third. And then that's being raised to the negative x over 2. And then here, 1 over 25, that's just 1/5 squared. And it's being raised to the negative x over 3 minus 2. Now don't let yourself get super confused with having so many sets of parentheses. The only reason why I have these inner parentheses is because of the fraction. I don't want it to look like 1 cubed divided by 5, okay? So our power of a power property says if you have a base raised to 2 exponents, you can multiply those exponents together, okay? So this is going to turn into 1/5 to the 3 times negative x over 2 is negative 3x over 2. And here I have my 1/5, and then I'm going to distribute my 2 here. So 2 times negative x over 3 is negative 2x over 3, and 2 times negative 2 is a negative 4. And just like before, we could take these exponents and set them equal to each other. So I have negative 3x over 2 equals negative 2x divided by 3 minus 4. Now I don't know about y'all, but I really hate these fractions. So I'm going to multiply those fractions by their least common denominator, okay? The smallest number that will cause those fractions to go away. So between 2 and 3, the first number I could think of is a 6. So I'm going to multiply this entire equation by 6 just to get rid of those ugly fractions, okay? So here, 6 divided by 2 is 3. So 3 times negative 3 is negative 9x. Now here, 6 divided by 3 is 2. So 2 times negative 2 is negative 4x. And then 6 times negative 4 is negative 24. Oh, and I don't know about y'all, but that looks a lot easier to me. So now we're going to try to get all our x's onto one side. So since I have this negative 4x, I'm going to add 4x to each side. And that leaves me with negative 5x equals negative 24. Now that negative 5 and x are being multiplied together. So I'm going to divide it by negative 5. So I get x equals a negative times a negative cancels out, and I get 24/5. Kind of an ugly answer, but there it is. Now this is a really long example, so we actually have another slide of example 3, and it's just practicing this stuff. So here we are. This one's kind of a big number, 256. Good gravy. Now, what I tend to do when I look at these problems is I think about this. So 4 is 2 times 2. Okay, it's 2 squared. So I can look at 256 in terms of 2. So I could divide it by 2 a bunch of times and see how many 2's there are. But I'm going to check first to see what happens when I divide 256 by 4. All right, so 256 divided by 4 is 64. And if I take 64 and divide it by 4, I get 16. And if I take 16 divided by 4, I get 4. So 256 is equal to 4 times 4 times 4 times 4. Okay, that's the same thing as 4 to the 4th. Okay, and that just came from dividing 256 over and over and over again. Okay, so I'm going to rewrite my problem to have that base of 4. So I have 4 to the 4th, that's 256, raised to the x plus 2. And this one's already 4 to the 3x plus 9, so it's a little less work. So then our power of a power property says that when you have an exponent raised to an exponent, you can multiply them together. So that's what I'm going to do now. So I have my base of 4. 4 times x is 4x. And 4 times 2 is 8. Now I can go ahead and set my exponents to each other because their bases are the same. So I have 4x plus 8 equals 3x plus 9. And now this is just a normal Algebra 1 problem that we can solve. So I need to get everything with an x onto one side of the equation, so I'm going to subtract 3x. So this gives me x plus 8 is equal to 9. And then I need everything without an x to the other side of the equation. So I'm going to go ahead and subtract my 8 from each side. And that leaves me with x equals 9 minus 8, which is 1. So now let's check this next one. So I'm going to try the same trick where I'm going to see if the bigger number is some kind of power of the smaller number. So I have an 8 and a 4. Now if I do 8 divided by 4, okay, I get a 2. So I can't convert these into terms of 4, okay, because this isn't 4 to a clean power. Now 4, I know 4 is 2 squared. So I'm going to go ahead and see if 8 is a power of 2 as well. Well, I know if I do 8 divided by 2, I get 4, because I just did this division problem up here. And 4 is 2 squared, so that means that 8 is 2 times 2 times 2, which is 2 cubed. So I can actually convert these fractions into a square and a cube. And that's what I'm going to do. So 1/8 is 1/2 cubed. And then it's being raised to the x over 2 minus 1. And 1/4 is 1/2 squared. And it's being raised to the x over 3. So now remember, the power of a power property allows us to take this power and multiply it to the other exponent. And so I'm just using my distributive property to multiply 3 to the x divided by 2 minus 1. So 3 times x over 2 is 3x over 2. And 3 times negative 1 is negative 3. On my right-hand side, 2 times x over 3 is just 2x over 3. So now we have that nice same base. So I could take my exponents and I could set them equal to each other. We have those dang disgusting fractions. So to get rid of them, remember we're going to go ahead and multiply by my least common denominator. So in this case, between 2 and 3, my least common denominator is 6. So here we go. So 6 divided by 2 is 3. So 3 times 3x is 9x. 6 times negative 3 is negative 18. 6 divided by 3 is 2. So 2 times 2x is 4x. And now it's just a normal Algebra 1 problem. So I need to get all my x's to one side. So I'm going to subtract 9x from each side. Now I don't like having all these negatives here. I don't need all that negativity in my life, you know. So if you wanted to do extra steps, you could add 18 and subtract 4x. But I'm also really lazy, so I'm just dealing with the negatives here, and that's okay. Now here, the negative 5 and the x are being multiplied. So to remove it, I'm going to divide by negative 5. And remember, if you have a negative divided by a negative, it turns into a positive. So this is a positive 18/5 for my x value. So there we have it. That's how we use a power of a power property. Until next time.